Did you know that a single bowl of fat could determine whether an entire family would survive the polar winter or perish from the cold? Not a fire, not a sword, not a store of grain. A bowl of rendered animal fat, with a twist of moss floating. At its center, producing a flame no larger than your thumbnail. That was the engineering marvel standing between a Viking household and the absolute darkness of the Norse winter. This is not poetry. This is thermodynamics. This is survival. Calculus. And this is a technology so elegant, so brutally efficient, that its disappearance from common knowledge represents one of the quiet catastrophes of human memory. Chapter 1. The Fuel of Desperation. Understand first what the polar night actually is. Not a long evening, not an overcast afternoon. In the Norse territories above the 60th parallel, winter darkness arrives like a physical presence, a weight pressing down on the longhouse roof for 18, sometimes 20 hours a day. For months. The psychological toll of sustained darkness on human beings is measurable, clinical, and severe. Now remove modern electricity from that equation. Remove gas. Remove the assumption that light is a right rather than a resource. Wood burns. The Vikings knew this. But wood was a luxury bordering on madness in a world where timber meant boats, and boats meant trade, and trade meant survival of a different and equally urgent kind. You did not burn your ship to stay warm tonight. You did not burn your structural timber to read by. Wood was capital. Wood was sacred. This was the fuel of desperation when all other supplies were running low. But fat was everywhere. Every slaughtered animal carried it. Every autumn kill, every whale beached on the shore, every domestic pig brought to the knife before the first frost. All of it yielded raw, unglamorous, miraculous fat. Think of tallow the way you think of modern oil. It was dense, portable, storable energy. Whoever controlled significant fat reserves in a Norse community was, without exaggeration, controlling an oil field. The parallel is not decorative. It is structural. Do you think that such a simple source of light as a tallow lamp could really have radically changed the lives of the Vikings? Or is this just an exaggeration? Consider this. A single tallow lamp, burning steadily through a 16-hour winter night, consuming perhaps 30 grams of rendered fat, produces enough light for close work, mending, carving, reading runes, nursing an infant. Multiply that across a winter of 100 nights. Do the arithmetic. Now you understand why the autumn slaughter was not merely a food preservation event. It was a light harvesting operation. Chapter 2. The Alchemy of Rendering Raw. Animal fat is not tallow. The distinction matters enormously. Raw fat is wet, biological, full of connective tissue, blood proteins, and water content that will cause it to sputter, smoke, and stink with a ferocity that goes beyond unpleasant. You must render it. The process is slow, deliberate, and it smells nothing like food. They would chop the raw suet, the hard fat from around the kidneys and loins of cattle or sheep, into small pieces. Then heat it slowly over a low fire in a clay or soapstone vessel. The temperature is critical. Too hot and you scorch the solids, releasing acrid compounds that will make your eyes water and impregnate every textile in the longhouse. Too cold, and the water fails to evaporate, leaving you with a product that will harbor bacterial decay. The correct temperature sits at what we would now measure as approximately 48 to 54 degrees Celsius. A gentle simmer, barely a tremor on the surface. Using modern visualizing tools to recreate these ancient methods, we can see the precise moment the fat clarifies into liquid gold. The cloudy, grey-white mass of raw sweet transforms, slowly and almost reluctantly, into a translucent amber liquid. The solids, called cracklings, sink or are skimmed. What remains is pure rendered tallow. The smell permeates everything. Your hair, your clothing, the wooden walls of the longhouse. A Norse family in winter smelled of tallow the way a mechanic smells of engine grease, not as a sign of poverty, but as the ordinary signature of their primary technology. You carried the smell of your light source on your body. It was not a stigma, it was evidence of competence. Now that we know how raw fat becomes fuel, the question arises, what do you burn it with? Chapter 3. The engineering of the wick butt fat. Alone is not enough. You need a wick. This is where the engineering becomes genuinely worth your reverence. A wick is not simply a string dropped into oil. A wick is a precision capillary system. Its function is to draw liquid tallow upward against gravity through surface tension, deliver it to the combustion zone at exactly the rate it can be consumed, and maintain that rate consistently across hours of burning. Get the capillary geometry wrong, and the wick drowns in its own fuel, or dries out and chars to nothing. They understood this without the vocabulary of fluid dynamics. They understood it empirically, through generations of observation and correction. Dried moss, specifically Sphagnum species, was one solution. Its cellular structure creates hundreds of microscopic channels running along its length, drawing fat upward in a slow, metered column. Rush pith, harvested from the soft core of bulrush stems, offered similar geometry. Twisted linen, when available, provided a more controlled and durable option. Simple in form, but ingenious in content. Each material represented a different calibration of the same capillary problem, selected based on what was at hand, what the season offered, what the household could spare. Chapter 4. The chiaroscuro of the longhouse. Now that we know how the fat burned and how the wick fed it, the question arises. What did this light actually do to human beings living inside a Norse longhouse? It created a circle of safety. This phrase is not metaphor. In the context of a structure where the corners lay in genuine absolute darkness, where children slept, where tools were stored, where animals sometimes shared the space, the eye radius of a tallow lamp's light defined the boundary between the social world and the void. Within that circle, you could see faces, you could read expressions, you could work, you could exist as a member of a community rather than as an isolated organism waiting for morning. The psychological architecture this created was profound. The flame organized the family. It assigned a center. It imposed warmth that was not thermal but social. People gathered toward light the way they gathered toward each other, because in the Norse winter, those two things were functionally the same. Chapter 5. A matter of life and death. This craft was once absorbed with a mother's milk. Every Norse child watched fat rendered, wicks twisted, lamps filled. The knowledge required no formal transmission because it was woven into every domestic hour of winter. It was not a specialty. It was not a trade secret. It was air. And now, it is gone from common memory, not suppressed, simply outpaced. Electric light arrived so swiftly, so completely, that the cognitive infrastructure for tallow technology dissolved within 2 generations. The knowing hands that could select the right fat, judge the rendering temperature by smell and color, calibrate the wick to the vessel's diameter. Those hands are gone. The flame they maintained was not symbolic first. It was thermal first, optical second, social third, and spiritual by consequence. When the Norse spoke of fire as sacred, they were not being poetic, they were being precise. The flame that kept your family alive through a polar winter earns its sanctity through sheer, measurable material service. There it is. The complete architecture of a technology that most modern people would dismiss as trivial. A bowl, some fat, a piece of moss, and that sustained human civilization in the far north for centuries. So here is the question worth sitting with. What do you think was the most ingenious part? The wick, the bowl, or the fat itself? Tell us which layer of this technology astonished you.